means at all. Hello!
Hey, what's up?
Happy Pi Day!
Happy Day of Pi.
We should write that down.
Yes.
Yes. We'll write it down up here. Oh, that's a great marker.
That's a nice marker.
Ooh.
Happy Pi Day.
Yeah, March 14th. That's why it's Pi Day, because it's like 3.14. Do we already have a message?
I think it's probably Stream Elements saying hi.
I hope so. No, it's not. It's Encryption XYZ.
Hello, Encryption.
Welcome to the dojo.
Welcome to town.
3.14159265392358932462 ... and on and on.
Doesn't it turn into Chinese after the first 30 or so?
Yes, it has a portion that's Chinese, then it goes back to Roman numerals. Sorry, not Roman. What are these, Arabic?
Speaking of, in Roman, alta ipsum means summon
That's
yourself.
way too quick. We only have one viewer. Yeah, it's Pi Day. So in honor of Pi Day, we're thinking about going really into circles. You know why? Because we're the sheriffs of Circle Town.
Circle Town is big enough for the two of us and everybody else in this black box here.
Is that true?
Yeah.
I happen to be of the opinion that Circle Town is not big enough for the two of us. I think it's big enough for just one of us.
But what about the two of us?
Oh, crap, I didn't consider that.
And who's the first one? Is it you or in me?
In general or just today specifically?
Yeah, well, today.
I didn't realize the badge.
Yeah, it's not a badge, it's a rite of passage.
Yeah, I remember when I got my badge.
Yep.
Very proud.
I had to dig it out of my dead father's heart.
Yep, they only made a limited amount, so you got to get it out of your father's heart.
Yep. It was a calcified blockage in his heart, killed him, and made a badge out of it.
He had to... Oh, I see. They made a badge out of it.
Yeah.
I thought the badge somehow ended up inside his heart cavity.
Well, to an extent it did.
Tuna?
Too much to an extent it did.
Too much to an extent. Very good. Well, I think we should go ahead and get on started here.
I think I should write out
What? What? What are you doing? We're talking about circles. I mean, we're talking about circles and what they do. Circles. What are they? How do I get involved? Great question.
It's Circle Town.
A circle is a collection of points where every point is equidistant from a central point. Here's your central point. Choose a distance. Go in any direction.
What's that distance called?
The radius.
Or, as some like to call it,
The radius.
there we go.
That's me. 5 in all directions, infinitely, gives you a circle. Which is, you can see what's going on. It's not the best circle. Maybe I should extend this a little bit. What are you working on over there?
I'm trying to draw the cityscape of Circle Town, but it's sort of looking like just boils on skin. You know?
It looks like a tombstone with tombstones on it.
I'm trying to demonstrate that it's Circle Town in particular,
Right.
but it's not.
Right, that makes sense.
What's going on there?
It's a lot of dust in the air in the west.
Swallowed the horsefly, did you?
Yep. My papa was a horsefly.
Yeah?
Yep.
Mama was a horse.
Fly horse.
A fly horse.
Yeah, she was a fly horse.
Yep.
Anyway,
How did that one work out?
I don't know.
All right.
First thing, circumference. Circumference is the distance around the circle. That's going to be 2 pi r. All right? Now, a couple pieces of terminology. These are all the radius, distance from the center to any point on the circle. If you double that and go all the way across the circle, like this, as long as it goes through the center of the circle, you have a diameter.
Bet you didn't know that. Encryption XYZ.
So 2 pi r is the same thing as pi times diameter.
Right. Pi d rhymes with high d.
Now, just to make things clear, pi is a ratio, okay, between the diameter and the circumference. What does that mean? If you have any kind of a circle of any size, whoa, and you find the diameter of any of those circles, let's say just you could have like a piece of string that you make that length. You got a bunch of them. It's going to take about 3 of those pieces of string to wrap around. You got one piece of string, you got another piece of string, you got one last piece of string, which almost gets you there, and then you got 0.14 pieces of string. That's what pi does.
That was horrifying.
What, the explanation?
No, the sound you made making it.
It's, well, you know, it's the South and it's the West.
Hey, Encryption, how annoying are we being right now?
Do you like this? That was a quick response.
Yeah, probably not responding. Ah.
LOL.
LOL is a unit of measure of how annoying people are.
1 LOL unit. Area is pi r squared. Alright? Don't forget that. Don't.
Right. And if you do, you'll have to remember it again, which is always no fun.
So you should
just remember it.
Yeah, don't forget it in the first place.
Yeah.
Let's run through a couple of drills.
Right.
Levi, you want to draw a circle?
Yeah.
Then go do it.
Do I have to draw it on the board?
That's true, Encryption. If you're taking the ACT, it's not going to be on there because there's no formula sheet, but the SAT does have it on the formula sheet. Draw a circle.
All right, I'm going to draw a circle.
Radius 7.
7 what?
7 radius units.
Right, okay. Let's say that we have this circle here. It's not a bad circle.
No, it's a very good circle.
Yeah.
Give us a radius of 7.
7 what?
7 inches.
7 inches.
7 inches.
Do I have to label it?
Of course.
Everybody always label your circles. If you don't label your circles, you don't know what's going on.
And they're going to throw you in jail.
You might actually make too big a circle and fall in yourself.
You
know what happens then?
You get digested by the hydrolytic enzymes that the circle will secrete.
Yes. In other words, you keep falling, and time, which is the digestive enzyme of the earth, will digest you over time. It's actually how everybody dies.
No way.
Aside from my father. He died from a giant calcified sheriff.
He's the only one.
Only one.
Radius is 7.
7 inches.
This should be very straightforward. Circumference is going to be what? Should I be scared of circles? If you don't want to be scared of circles if you make circles scared of you.
Do not show them fear. They can smell it.
Yep.
And the circle will swallow you up.
Boy.
Boy.
All right, what's the circumference?
Of what?
Of that circle.
Oh, of that circle. Well, I would say it has to do with that.
Hope so.
And we're going to throw in a 7 for the radius, because that's the radius.
2 times pi times 7 is 14 pi. So wait, does that mean that 14 is the diameter? That's right. That's right.
Always use your units. If you do not use your units, your circle may get too big without your permission and swallow you whole.
Exactly.
And then digest you.
With hydrolytic enzymes secreted by the circle. Your area is pi r squarea. Listen to that. Pi r squarea is your area. That's how you remember. Pi times 7 squared.
Hey, Encryption. As quick as you can, give us the equation of a circle.
If you want to graph a circle, what's the equation? As quick as you can. You got to be a fast shot.
Go.
Ba-da-dum, 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 bum, bum. You put your rags away.
They're not rags, they're...
Partner, you got a couple of rags. Yeah, that's close.
Right. So that's close, but wrong.
Here you go.
X
yeah, that's pretty
H
close. You're forgetting your
minus-
parentheses and it's plus in between. No, I see what you do. Yeah, it's plus between. Yeah, I think he would have gotten it if he had the right.
Yeah, that's way too many variables, though.
No, it's close.
SOMETHINGI, whatever.
Yeah, no, and
You
then
said
you did
quick.
what we wanted you to.
You gotta draw quick, but you gotta aim good. Remember, accuracy over efficiency. Right?
Yeah, that's what we always tell him.
Yeah.
X minus h squared plus y minus k squared equals r squared. What is the center?
Quickly, Encryption, before the circle gets you. And what's the radius?
Which variables represent the center? Good. H comma k.
That's great, Encryption.
What about the radius?
You live another day.
You're forgetting the radius. Happy Pie Day.
Hey, Storm, welcome to Circle Town.
We're sheriffs here.
Yeah, well, I'm the sheriff. He wears the badge.
Yeah, it's R. Over here, you got your radius squared, but R is just the radius by itself.
Right. You gotta watch that voice of yours. You're gonna think the circle's gonna think you're scared.
I've been speaking like this since I was a wee chap.
A wee chap, huh?
Yeah.
It's horrifying.
Why?
I'd be horrified to meet a wee chap such as yourself.
Clean up your circle, bozo.
Right. Anyway, Storm, you got any questions for us?
Ideally.
Oh, we're not getting rid of this?
Specifically not yet. Yeah, rid of that.
That's what I decided without you. I did not ask permission. Did I?
No.
Did I ask permission?
No.
May I ask permission?
Yes, you may.
Right.
You gotta get some of this.
I'm gonna get it.
Okay, I'm gonna get rid of that frog. Gonna kill that frog.
We're a CB turtle when you need. Turtles and frogs are not the same animal.
No, they are not.
Never mind. They used to be.
Back before the accident.
Yeah.
And then all the animals were split.
The Great Schism, they called it.
Yep.
Great Animal Schism of
1812.
1812 on Pi Day. That's actually why we're talking about it now.
Very good. Okay, let's do one of these. So, Levi,
No.
I want to give you one of these. I want you to draw it.
Okay. I thought you got rid of the frog in your voice.
He came back.
I see that. Well,
All right. No more frog. No more frog. Let's see.
No more frog.
X minus 7 squared plus y plus 4 squared is equal to, I don't know, let's go with 64. Can you draw that?
I can try. It won't be to scale, though.
That's okay.
Well, it depends.
You get to create your own scale.
Right.
That's the beauty of math.
All right. So how am I going to do this? Let's just see where I'm going to draw this thing.
Don't be afraid to really get in there and get your hands dirty.
I'm going to get my hands real dirty.
Say y'all.
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 You say y'all.
To your computer screen. Just say it out loud.
If you all say y'all, if y'all say y'all at once, y'all will all just be saying the same thing. Y'all will all?
Y'all all.
Like, you all will all say the same thing, so y'all will all?
Tra-la-la-la-la-la-la-la-la, tra-la-la-la-la.
I hated that.
Why didn't you like that? You remember that video?
No, I don't remember the video.
Any of you guys remember the Tra-la-la video from a couple of years back? I hope so. I hope I'm not the only one.
It's unlikely. Right, so we have x minus h, y minus k. And our center is hk. Now, not to be confused with minus h and minus k. So here we have minus 7, which means the x-coordinate of our center will be a positive number because we're subtracting h. Which means that we have 1, 2, 3, 4, 5, 6, 7.
Yep.
And then our y value will be negative 4 because we're subtracting a negative 4. That should be minus k, so if you got a plus here, it's got to be minus negative 4. Storm, do you have any questions? If not, blink twice. All right, so this is, oh darn, poorly chosen.
You done screwed up.
That's our center. Let's call it center B. Now, we have, what's next? Oh, right, the radius. The radius squared is 64 according to this equation. So our radius just by itself will be 8. So we're going to go at 7, so we got one more. We're going to get a point on the outside of the circle there. And then we're going to go up 4 and then up another 4 to get to that other half of the radius.
This is going to be partially off screen. That's okay.
Yeah, just use your imagination. That's what we're doing now.
Connect them.
Right. With a straight line?
No.
Right.
Egypt with a curve.
I thought you just called me an Indian.
Egypt.
No, I thought you called me.
No.
One of those Native American folk.
Egypt. Yeah,
Right,
keep
right,
doing
right.
this.
All right.
Keep going.
And then it goes down like that. I'm sure you all know what a circle looks like. How a circle do. Right, so it goes like that. That's your circle there.
I called you an Egypt.
Egypt.
Don't be an Egypt. Keep going.
I'm trying not to be an Egypt. I'm trying not, okay?
Do your best.
Yeah, I'm doing my best.
I know.
Right. And now, this is actually the derivation of something very important that will be on both tests, but has never been on the test up until this point. You have your, how do I want to do this?
Have fun.
No, Brady.
Well, I thought this was only big enough for one sheriff.
Yeah, you know what? Why don't you shut up? So,
very polite.
This is your center B. But, if you draw a radius straight to the right side, you're going to get a radius here. You write in radius, but if the center is B, that's where you get your radius from. So that's a derivation. It's going to be one of those last questions where it's one of those ones where it's more you know it or you don't, but you know it. I don't think anybody else knows it aside from those of you watching now.
I don't know it in my heart.
I didn't like that.
In my heart.
I don't like when you talk like that because it's hard for me to pay attention.
What'd you step on?
I stepped on my foot, but it's more what my foot stepped on.
Okay.
Yeah.
Very good.
Yeah.
All right, so that's a Brady. It's pretty exciting.
That's a derivation of the Brady's. Now, more important. Let's drop this.
Hey.
No, I'm gonna.
What?
Dance jig.
Jig dance.
Jig dancing.
Yep. What you want to do?
Well, I was gonna show the derivation of this here equation.
Oh, you should.
Hey, encryption. Close your eyes and then type out real quick this equation, but don't cheat. We'll know.
We got eyes on the back of your kitchens.
We have that. We have eyes on the back of your head.
We have those eyes.
Yes. You think you're using them? No.
It's like Voldemort on the back of Professor Quirrell in the first movie. We got like that on the back of your head, but unbeknownst to you. We got one little viewer.
Do we?
They've left.
That's ideal.
Who's still here?
I hope no one.
It's Circle Time.
Circle time.
Everybody loves Circle Town.
Are you sure?
Happy Pie Day. What?
No, don't worry about it.
We got to keep going.
Probably not.
What, we don't have to keep going?
Well, sometimes when you stop, you're actually keeping going.
It says that one eyeball.
Who says one eyeball?
The bottom of Restream.
Oh, that's good.
It puts them all together.
Do it.
Did you not know that?
No, I didn't know that.
Okay.
Did you?
Yeah, I did.
Right, that's why you told me.
That's right. That's how that works.
That does. I like when people impart information that they don't know.
Yeah?
Yeah. It's like body language.
Have you heard of that band, Olche?
No, have you?
Nope.
Oh.
Well, looks like nobody's heard of them.
Well, you made a good point.
Yeah. Okay. You're going to derive this or something?
Derive. Yeah, maybe. I don't know what's wrong with
I don't
this
know why
thing.
it does that.
Maybe
This one's
it's
pretty
just
good.
sad. No, you always use so much water.
Well, you would be too if you were a squirt bottle.
But no, I'm talking about you.
Me?
Yeah.
I'm sad?
No, I didn't say you were sad.
Why would I be sad?
Your words.
That's not what happened.
You made up that word, sad.
I need more water.
No, you don't need more water.
What about this?
That's when you use your other rag.
No, I got one wet rag, one dry rag.
And see, it's gone.
Well,
Right. All right. We're going to be at each other's throats real soon, so please ask us some questions.
our viewers just doubled.
That's awesome.
Yeah. Yeah.
Remember, if you ask us questions,
You ever seen that movie?
you a great deal of money.
You ever see that movie, The Best Around?
No.
I haven't either. Have you heard of it?
No. Have you?
No. That's
Right.
bad.
Hey, y'all got to ask us some questions. Circletown's a real lonely place this time of year. Don't get many travelers. There seems to be a handful of you now, so please ask them some questions regarding the SAT or ACT. Thank you.
Circletown is big enough for the two of us right now because it's only got the two of us. There's 2 sheriffs in town, and they're sheriffs for each other.
For those of you to whom this makes absolutely no sense, that's fine. 1, because it's stupid. 2, you may have missed the sheriff star on both of our chests.
We gotta get cowboy hats.
Yeah, well, sheriffs aren't necessarily cowboys.
No, but they wear the hat.
I feel like you could explain to me why they call them cowboys when they sit on horses. Unless
They
all the...
wrangle cows.
Right.
They're
the
wrangling.
horses wrangle cows?
Well, the cowboys and the horses wrangle cows.
Question.
Yeah.
In the horse community,
Yeah.
there are horses that are ridden by boys, and then there are horses that are not ridden by anybody. So do the general horses that are not ridden by anybody talk to the horses that are ridden by boys and say, you're a boy horse?
Now that's a good question, and I don't know the answer to that.
Like old Eastern movies that
Right.
the horses
The
do?
good, the bad, and the ugly? Old Eastern movies?
Old Eastern movies, yeah.
Yeah,
I'm sort of inverting all the normal tried and true things because
I
we're
get
talking
that.
about horses now.
I get that.
Right. I thought I had to explain it to you.
You didn't have to explain to me nothing. What do you want
Right.
to do next? You want to do sector areas and arc lengths?
I really would like everybody to ask us questions. The last time...
Radians and degrees. Sorry, you could have kept doing that.
No, it's okay. I'm doing
We
myself.
can talk about converting, right?
Probably should.
Yeah, why not?
What happens if we don't?
I don't know. The Radian deity will shower on us lightning bolts.
It's actually where the word radiant came from. It's a halo around somebody's head is radiant because it has a radius. Did you hear about that?
Yeah, why not?
Right. You have no idea what I said.
Well, yeah, I get it because it's radiant. I get it.
Oh, I get it. I didn't get it before when I said it.
Right. You got 2 different ways to measure angles. You got degrees, you got radians. They're both measures of angles, okay? So you can convert them to each other, and this is how you do it. 306 degrees is equal to 2 pi radians. So you can do a little bit of a simplification by dividing both sides by 2. And when you do that, you're going to get 180 degrees is equal to pi radians. Okay? That's going to be your conversion factor. You could have used 360 equals 2 pi, but it's a little bit easier to use 180 equals pi. So Levi, give me a degree measure.
2 pi.
Give me something good. That's not a degree
Right.
measure.
360 degrees.
Well, you could make it 2 pi degrees, 6.28 degrees.
Yeah, but that's what I was saying the first time. But I don't want to do that
That's
to you
way
because
too
you're
complicated.
explaining a concept for the first time.
It's pi day.
Yeah, it's pi day. How about 30 degrees?
30 degrees. You got it. All right. We're doing unit conversion here. We're going to use dimensional analysis, which is where you make a fraction and you multiply by a conversion fraction. Okay? We want degrees to be gone. We want radians. Thank you. So we're going to use this. 180 equals pi, but we're going to put degrees so that they're going to cancel out degrees up here. So we're going to put it down here. 180 degrees, and on top we have pi radians. So what this is going to do is units are going to cancel, leaving us with just radians, so we just have to multiply this out. We have 30 pi over 180. We can cancel out, we can divide both by 10. We have 3 pi over 18. Those are both divisible by 3. If you do that, you're going to get pi over 6 radians. So 30 degrees is equal to pi over 6 radians. Levi, you want to do one?
Yeah, I could.
Why don't you convert from radians to degrees?
Right, I'll do that. Let's say that we have 3 pi over 4 radians. We're going to degrees, so we're going to multiply that by 180 degrees over pi radians. Our radians cancel. Actually, our pi's also cancel. We have 3/4 of 180 degrees, which is 135 degrees. Everybody understand? I'm sure you do.
I'm sort of getting annoyed by the accents. Actually, it's technically a dialect, but if anybody wants to keep hearing this, please let us know. If you don't, we'll stop. Right?
Right.
Ugh.
We could just be like permanent grandmas.
I'm fine with that. That's how most grandmas are.
Yeah, darn tootin'. You converted Radians degrees, nice.
I did.
Oh no, your
you
Circle Town
not?
picture.
Oh, that's all right. Circle Town had to go.
Every town has to go.
That's true. We're
God,
swallowed
just
by a circle. It's,
Bomb them off the map with that nuclear bomb.
I'll show you a nuclear bomb. You know where?
I'd prefer not to say.
Right. I think on the test site in New Mexico, right? Isn't that normally where you see them?
Yeah, that's why they call it. Remember the Alamo, because they nuked the Alamo, and it's like they shouldn't have done that.
I thought that had something to do with the Sesame Street character.
The Alamo.
Yeah, remember
I'll
him.
remember Elmo.
Because that's no longer being shown.
Right, so they don't want to forget Elmo. Elmo never forget. Yeah, that makes sense. I do wonder, like, how many people I went to high school with that are just seeing this pop up on their newsfeed. And I'm just like, what is he doing?
I don't think they'd say it like that at all.
No, I went to school with a bunch of Texans. He was so full of promise, and now he's...
It was so full of promise.
Oh, God, so promiseful.
He made so many promises to us.
Lots and
I
lots.
specifically promised everybody in high school that I would not do this.
You're right.
Yeah, they were like, Levi, you seem like the type to do this. Please don't. And I said, I'll never.
Yeah, and that was before Twitchy was even out, but they were just saying, if there's ever some kind of a platform that video gamers use to stream themselves live and you decide to do it as like a pro bono tutoring type thing, and you do like Western accents, please don't do that.
And I said, I won't.
He said he wouldn't.
But you know, what they don't know can't hurt them. Even if it did, it wouldn't hurt them because that's dumb. And we made it up.
Sticks and stones. Sticks and stones. All right, what do you want to do next? We got sector area and arc light.
And,
That's not what I sound like.
oh,
I'm sorry.
you gave me the clap.
I struck you. No.
Sorry.
No.
I didn't mean to.
No.
What about this? Why, look at these. Look at
Those are
colors.
pretty colorful. Those are pretty
Just
colorful.
forget.
Well, I'm gonna try. Jeez. Don't do that.
I didn't do nothing.
Yes, you did.
Oh, but what if you forget?
Well, I won't. I never do. We gotta stop.
Yeah, you gotta remember the Alamo.
I never do. All right. This is ridiculous.
That's not a circle, that's a lima bean.
You're a lima bean.
Do you know the first 50 digits of lima bean?
Do you?
Yeah.
Let's make. What do you want the radius to be?
R.
No.
Oh.
Let's make it 12. So real quick calculations. Circumference is going to be 24 pi. Area is going to be what?
A.
Be more specific.
144 pi.
Okay. Here's the idea.
What, are you doing sectionaries?
I think so.
Sectionary, oh God. Wait. Sorry.
What?
I don't know, I feel annoyed right now.
No.
Right.
You don't know that.
No, I do feel that way, so I know that.
Hold on. Hold on.
What?
What are you doing? Oh, jeez. I have to just fix everything. Now, don't worry.
I'm not worried.
Give me the vertical one again.
Vertical what?
The vertical of the right angle box.
Okay.
Okay. There we go.
Oh, thank goodness we did it that way.
Yep.
Right, so, hey, Bird.
What?
What's the area of this?
Well, that's a good question. I'm going to go ahead and say that right angle is a quarter of the circle. And if that's so, it's probably going to be a quarter of the overall area. I know that the area is 144 pi, so it's probably going to be a quarter of 144 pi. So I'm going to take 144 pi and divide it by 4 to find a quarter of it.
It's 36.
144 pi divided by 4 is going to be what? It's going to be 25 plus 11, which is 36 pi.
That's interesting. I just divided by 2 twice. 72, 36. We came at it 2 different ways, arrived at the same place.
Multiple points of entry. It's what makes math so exciting.
That's not why I like math.
Why do you like it?
You get to shoot people.
That's not. What kind of math are you doing, boy?
The sheriff math. Don't know where my button
If
is.
I have 6 sheriff bullets and there are 2 outlaws on the run, how many different bullets can I sink into the first outlaw while still having 7 for the second? And the answer is -1.
-1 what?
-1 bullets. You remove 1 from the first one, and then you still have 6 for the other.
You know how they did that movie Cowboys and Aliens?
Sorry, you have 7 for the other. Yeah,
Maybe we could do Cowboys and Witches.
that's fair. We
It's
should
not
have,
unfair.
We should have witch characters. That'd be fun.
It's not a bad idea.
Do you think we're humiliating ourselves right now? Because I'm having a good time.
I think at least one of our viewers is my father.
Does he know how to, like, message us?
No, he doesn't have no account.
Ah, I see. Okay.
He's just there.
He's just there.
Hey, Daddy.
Okay, so what about this little arc length? This length right here.
Well, if you measure it along the orange line that you just drew, I couldn't tell you.
Well, don't do it
But-
like that.
But a little Forrest Gump.
A little bit.
A little Forrest Gumpy.
Yeah.
Forrest Gumpy.
Yeah.
Did you too?
No, I'm just fixing this.
Oh, right.
Keep
Oh,
talking.
it was me.
Keep talking. Rootin' tootin' toots. Not in this part of town, no sir. I'm the sheriff.
That was such a lackluster. No, sir.
You gotta cheat out.
Stop.
Stop. I'm the sheriff.
Stop. Stop.
Be gentle.
Right. So, same idea.
Very good.
Same idea. Same idea. Same idea. So
Keep going.
it's just a quarter of the circle. So a quarter of the circle.
Quarter.
A quarter. A quarter of the circle, not to be confused with quarter of pants. Which
Quarter.
are corduroy.
Oh, I see quarter of pants.
Quarter.
It
Quarter of
smells
pants.
so bad.
Was that you? I thought it was. That's awful. That's not nice, man. We're in a small black box together.
You don't know that.
No, I do. You know how?
How?
From the concentration of your dude entering my nostrils.
Get out of here. All right, it's a quarter of the circumference.
I'm dying.
Circumference is 24 pi. Here we go. Divide that by 4, you get 6 pi. And we should just designate that this is the arc length. And this is the sector area. I love Pi Day. Always have.
We're being so productive.
So production oriented.
Great deal of production orientation.
So can we kind of summarize this in some kind of a relationship?
Pie. Oh.
You know?
Right,
Circle ratio?
right. Yeah.
Where's my rag?
I think you probably burned it up.
No. No.
You don't talk much like a sheriff.
Well, you know.
Well,
so-
okay, so what? I can't draw it now.
We
Oh
got
my
it right.
God! I think we have quite. Stop it. Would you stop it?
No.
This is horrifying. Look, you've just covered the board in wet.
You don't know about that.
I know exactly about that. I'm dealing with it as we speak. What is the schmuthing?
Get out of here.
The slope. The slope.
The slope of the line. The slope. I love Pi Day.
That's so funny.
All right, we gotta get up this relationship.
We will once we can dry off the board enough. You covered it all in wet.
That's not true.
No, you can't. That's not a valid argument.
Do you
just
have
to
any
say no.
evidence? of such a preposterous accusation?
Yeah, it's the wet on the board.
Yeah, but that was you.
No. Was it?
Do you have any cameras recording it?
I think so.
Do you know so?
No, according to Descartes, I only know that I am. Not anything else.
Descartes. Getting a lot of questions today. Please ask us your questions.
Where's Robot Dancer when you need him? He had some questions about quadratics today.
Forget robot. What about Honomero?
I don't know, but I think if you keep pronouncing her name like that, she'll never come back.
You're right. Okay, in general...
Wait, no, I want to do it.
No, I'm just going to draw you a circle.
Don't
worry.
No man has ever drawn a circle for me.
Well, this is your lucky day.
Thank you.
Yeah, whatever. It's on the house, I guess. Trying to give you something to do with color coding.
Coating it in color.
Have fun.
What did you do? That looks like a pizza with one lone pepperoni.
Yep.
That's no good. Ugh. Hey, bird. I never see you anymore. What you doing?
Oh,
Ah,
I'm tending to my nest.
bringing some fluff to it for your babies?
I'm a bird.
For now.
For now.
So, on the bottom here, we have the whole circle, and on the top, we have the sector. So, what this means is that whatever theta is of your angle here, you're going to put that on top. And then you have 360 or 2 pi, depending on how you want your answer. So degrees or radians. And then the sector area, the area of this sector will be proportional to, or the sector area over the area of the entire circle, the whole thing, right? Which makes sense. As you expand pi, right? If pi is 90 degrees, then it'll be 1/4, right? 90 over 360 is 1/4. That 1/4 should also make sense for this ratio right here, which is the area of the sector over the area of the whole thing. Same thing with the length of this arc over the entire circumference. Same idea. Okay.
Getting a lot of questions today.
I know.
Listen, this is just our way of figuring out what works, right?
What?
I'm just saying, all these characters.
Oh, for sure, for sure.
Absolutely.
But I think yesterday people liked it, but it was only in the last 30 or so minutes.
That's absolutely true. I shouldn't forget or neglect that.
You should neglect and forget nothing.
Neglect.
All right. So we did a lot of circle stuff. Maybe talk about the unit circle. Mine is Pi Day. Right. I can't do it on stream.
Why not?
Because it's weird.
Right, and we're trying to keep this stream very normal.
This is so normal right now. This is not, if you're watching this,
This is way more normal than not watching it. Everyone else that's not watching it is not normal.
What's going on right now is absolutely nothing. If you're watching this stream and you want to learn something, I recommend you ask us a question about the SAT or ACT or Brady's personal life here, because I will answer all of those things at once with equal amount of verve.
Verve? Yeah, verve.
Verve.
Maybe we should just clean this up a little bit.
Yeah, don't touch anything. I'll do it.
All right. Levi's got some ideas about how much water I can use.
We're having a water crisis.
Who?
We.
You and what army?
Me and you, Army.
The army of the living dead. Ooh, brains. Right? Like zombies?
It's like zombies, but alive. And
Right.
not sick.
You ever wonder what would happen if there was actually a zombie apocalypse?
I do.
What do you think would happen?
Well, I don't see it being any better or worse than a normal apocalypse.
Oh, there's definitely better and worse apocalypses. Ellipses. Pi Day? It involves pi.
Yeah.
The
That's
area,
true.
at least. We got to talk about pi. And pi, radians, is in the unit circle. There's much more to be done.
Doubt it.
You
I doubt
doubt it. I doubt you and your existence. Just take those old records off the shelf. Hey, I sit and listen to them by myself. Today's music ain't got the same soul. I like that old time of rock and roll. Okay, let's talk about ellipses. There's really only one thing you need to know that involves pi and ellipses. You got yourself your vertical ellipse. You got yourself your horizontal ellipse. You got what I like to call the horizontal radius and the vertical radius. Never mind, I don't call it that. I call it the x radius and the y radius. A and B. A and B. A is the x radius. B is the y radius. Now, normally, area of a circle is pi r squared. But in this case, we have two different r's, A and B. So accordingly, area of an ellipse equals pi A B. Pi times the x radius times the y radius. Pretty exciting if you ask me. But if you don't ask me, you wouldn't know that it's very exciting. You probably... Where do my rays keep going? Oh, they're on my shoulder. They were on my shoulder the whole time. Unit circle time. Or as the French say, unit circle. There, I can serve water. Are you playing solitaire over there?
No. Are you?
Yep. Currently playing solitaire as we speak.
Hey Bird, we got this question on Discord. Should I cancel my score sends if I definitely did worse this time and have never sent them before? These are my first score sends, but my second test.
Do they know what they got yet?
No.
You should not send scores in automatically without first seeing the scores. Do they know what scores they got?
I don't think so.
Yeah, you should never do that. Cool water. Cool water. Okay. The unit circle. What a wonderful phrase. That means no worries for the rest of your days. It's all problem-free. Trigonometry tool, unit circle. Tool. The unit circle is aptly named because it has a radius of 1 unit. Hence, it is possibly the simplest circle we could ever think of. This is the y-axis. This is the x-axis. We have a radius of 1 unit, therefore, this is 1, 0. This is 0, 1. This is -1, 0. And this is 0, -1. The unit circle is a tool for help us to figure out the sine, cosine, and tangent of certain angles that are very, very prevalent that come up a lot. They're called the reference angles. Reference angles are things like 30, 45, 60, 90, 180, 270, 135. These are multiples of 15 and 30s, things like that. Not every single one of them, but I'll show you what we got. So, let's see, we've got, you should probably know that one, 45 degrees. I'm going to make that a little bigger. I love the unit circle. Love it. My daddy was a unit circle.
Before the accident.
After the operation. 45. Then we want to get 30 up there, which is 2/3 of the way to that. And then we got 1/3 after that. 30 degrees. 60 degrees. Now, I also recommend that you should memorize these angles as radians as well. So we got pi over 6, we got pi over 4, we got pi over 3. All right, I'm not going to write them up, but that is something that you should try to memorize. It'll make certain calculations a little faster. All right, halfway from 90 to 2, well, hold on, take 270. That's not 270, that's 180. Excuse me. 180 degrees. This right here is 270 degrees. This over here is 0 degrees, but it's also 360 degrees because it keeps going in a full circle. Up here we got 90 degrees, which you should know. What's halfway between 90 and 80? It's 90 plus 45, which is 135. 135 degrees. Then we've got this one. And we've got this one. This marker is not doing that well. I had such high hopes for it. This is going to be 15 minus that. So this is going to be 120. And this is going to be 150. Very good. Very good. Okay. I got to get a different pink marker. There's a reason why I'm having you do this, is because well, I'm doing this for you, is because there are sines and cosines that go with these that are very easy to remember if you can keep them all straight. Oh, that's good. That's also good. And that is also, in addition, good. It's getting worse now. Okay, halfway from 180 to 270 is going to be plus 45, which is 225. Not one that people know that much. And then we go down to 210. Then, ooh. Okay. 210 degrees. 240 degrees. Okay. 180 plus 120 is one way to think about it, which is going to be 300 degrees. 315 degrees. 330 degrees. Okay, so when we talk about the sines and cosines of all these angles, what we're talking about is their x and y terminal points. Terminal points are where they hit the circle. Okay, so 30 degrees, for instance. If we pull down a line here, make ourselves a little right triangle, this here, this x distance is going to be the cosine of 30 degrees, and this y distance is going to be the sine. Now let's just go over that real quick just so you understand that. I'm going to redraw that triangle. One thing that we know is that the triangle has a hypotenuse of 1. This is a right angle, and this is 30 degrees. So if I'm trying to solve for the x and y of this, let's just use some simple trig. I'm going to say, let's start with sine of x. Sorry, sine of 30 degrees. Let's see what that gets us. If we take the sine of 30 degrees, which is that angle right there, sine is opposite over hypotenuse, which is going to be opposite, is going to be y, over the hypotenuse, which is 1. Now, anything over 1 is just itself, so I'm just going to get rid of that right off the bat. So it turns out that whatever the length of the side y is will be the sine of the angle, which is pretty exciting. Sine of 30. The reason why it's working out so well is because our hypotenuse is 1. If we take it over the hypotenuse of 1, it's just going to stay itself. Now, a cosine 30 is going to be x. Cosine 30 is adjacent over hypotenuse, which is x over 1. So this right here is cosine 30. So there's a general formula here with all these triangles. Looks like this. Theta is the angle here. Sine of theta will be here. Cosine of theta will be here. And this terminal point is going to have the coordinates. Well, the x value will be cosine theta. The y value will be sine theta. So on the unit circle, the coordinates of all these terminal points is exactly how we figure out the sines and cosines. So there's a couple of values you should know. Degree measures that are 0, 90, 180, and 270, and 360 for that matter, are all very simple. You can see the coordinates, their terminal points, okay? So the cosine of 0 degrees is this terminal point right here. Because 0 degrees is just a line that goes right here. Goes all the way to 1. Its cosine is 1, its sine is 0, it doesn't go up at all. You can see 90 degrees has a sine of 1 because its y value is 1, but its x value, its cosine is 0. 180 degrees has a cosine of negative 1, a sine of 0. 270 has a cosine of 0, but a sine of negative 1. The reason why cosine and sine oscillate between negative 1 and positive 1 is because that's how far you can get up on a unit circle and how far down. If you think about sine, as you move an angle around the circle, this will be my angle here as I move it around. This right here will be the sine value. It's the height of the terminal point. Goes up to 1, starts going down to 0, goes down to negative 1, goes back up to 0. So watch how my hands do this thing right here. I'm tracking the y-coordinate, which is the sine. Similarly, the x-coordinate is the cosine. So we go from positive 1 to 0 to negative 1, then back to 0, and then back to positive 1. Look at my hands. Look at how I'm tracking them. This hand that goes left and right is the cosine value. Very exciting. Very exciting. Okay? So those are the easy angles. The ones in between are a little tougher. You got to remember a couple of different things. Okay. Oh, geez, that doesn't look that great. Well, the circle's not meant to be perfect, but it should be a little better than that. Okay. Okay. Oh, yeah, it's not that. And then this. Okay. There's going to be 3 tick marks on each of these axes. They represent the following values. 1/2, root 2 over 2, root 3 over 2. All right? This is 1/2. This is root 2 over 2. And this is root 3 over 2. Okay? Those 3 values are also found here. 1/2, root 2 over 2, root 3 over 2. And we have our negatives. Negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 3 over 2. All of our angles match up with that. Okay? It may not look like it because this is not a very well-drawn circle. But for instance, 30 degrees has a sine of 1/2. Oh, that should be higher. That's why it looks terrible. Oh, geez, hold on. Let me make this a little bit better. I am putting a lot of gump into my accent.
You are?
Yeah. Well, you know, what are you going to do?
It's okay.
Gump is a good movie. Have you seen it?
Gump with it.
That doesn't answer the question. Okay. There we go. So we have 1/2, root 2 over 2, root 3 over 2. There we go. So 30 degrees, you take it to the y-axis. You see that as the sine of 1/2. You take it down, you see that it is a cosine of root 3 over 2. This is root 2 over 2, and this is 1/2. Okay? This is why this whole thing works. You take 210, for instance. You bring it up, you bring it over. You bring it up to get to the furthest hash mark, which is going to be negative root 3 over 2. So that's its cosine. You bring it to the y-axis, which is where you put sine, and that's negative 1/2. That's its sine. Okay? This is a unit circle. It gets pretty complicated, but it is a lot of fun. All right? And you can also see what angles have the same sines and cosine. Like if I keep this negative 1/2 thing going, I get to 330. So 330 and 210 have the same sine value. They have opposite cosine values, though, because 330 has positive root 3 over 2, and 210 has negative root 3 over 2. Levi, this is getting really complicated. It looks good, though, doesn't it?
Yeah.
Really? Do you really think that? No?
What?
Why'd you say you did?
I do.
I'm still a sheriff. Yeah, unit circle, circle town. Woo! What time is it?
9.
9. We gotta get some questions.
Yes.
Glad you agree. Come on, you guys. We gotta get some questions. I'm gonna erase this now. Well, I can do one more thing. This is created with a bunch of 30, 60, 90 triangles and 45, 45, 90 triangles. All right? 30 degrees, 30, 60, 90. 45 is a 45, 45, 90. 60 is going to be a 30, 60, 90 triangle. And all the rest of them are going to be negatives, but they're going to be the same kind of triangle. So you can look at this and you can figure out what the sines and cosines are, also based on your special right triangles. Here's an isosceles right triangle, which means that these are going to be 45s. All right? If our hypotenuse is 1, we know that the sine and cosine of 45 degrees is going to be root 2 over 2. Root 2 over 2, root 2 over 2. So if I want to turn this into more of a standard thing, I could call this x. I'm going to call these all root 2 over 2x, root 2 over 2x. All right. Now, I don't really like this format because if you multiply everything by root 2, it becomes a lot easier to keep track of things. So I'm going to do that, and you'll see what's going to happen. Times root 2 over root 2. Is that going to be messy? No. Times root 2. And then times root, I'm just multiplying everything by root 2. That's why, not root 2 over root 2. I can do this because they're all proportional. So I can multiply them all by the same thing and the relationship will still exist. Root 2 times root 2 is going to be 2. So we're going to get 2 over 2x, which is just going to become x. So this is just going to be x. This is also just going to be x. And then here we have root 2 times x, which usually is written as x root 2. All right, so if you see relationship where you got two the same sides on a right triangle, it's got to be 45, 45, 90. The sides are both x. The hypotenuse is x root 2. It's a good time. Great way to stay in shape, too, for those long ranges you do. I'm going to need a lot of water to erase this. My gosh. Good thing I don't have Levi to tell me to conserve water up here. I can double barrel it. What are you looking at, Levi? What's going on the interweb?
Well.
And then fun.
No.
No. That's impossible. There's always something fun on the internet. Right?
Mm-hmm.
Good. I love streaming. In fact, I love it so much I'm streaming right now. You probably couldn't even tell. This is a stream. It's not actually me inside your computer. I'm actually in a different room. Gotta let it dry. I could just write out digits of pi for a while. Think people would want to see that? I feel like we don't talk anymore.
Mm-hmm.
Is that wrong? Levi, I got nothing to say. No one's saying anything. You gotta rescue me.
Yes.
That doesn't help.
Okay.
Come do stuff.
What stuff?
I don't know. Stuff, you know, stuff.
I'll help you erase, but you got to talk the rest of the time forever.
That forever.
Yeah.
Up until we die.
Yes.
You never gonna talk until you die?
Are you-
That's not gonna go well, I'll tell you that much. Good luck.
What?
I need a break.
What do I need?
Kit Kat bar?
Can I?
Do you want one?
Could you give me the Thin Mints that are upstairs?
Oh.
You can have some if you get them.
Fine.
That's what I thought.
Fine.
Oh, and then we can eat Thin Mints and talk about Alta Ipsum.
No.
Yeah?
Yeah, that sounds good.
Does sound good, doesn't it? Okay. We've done a little bit of this and a little bit of that, and that's good. I'm going to pull up the overlay and we can talk about some other stuff. The stream overlay. Maybe I can bring it up. This is so stupid. There we go. Give me a second. Oh boy. This is going to take a while, so just give me a second. I apologize if we lag. I don't know how much lag there's going to be with me doing this.
It's been so long since someone said something.
Yeah.
Kind of desolate.
Very Forrest Gumpian.
That's so good. Have another one?
Yeah.
Thank you.
Well, not doing that question. Not doing that question. Thank you.
You want to talk Alta Ipsum?
Yeah, let's talk a little Alta Ipsum.
Alta Ipsum. In Latin, it roughly means summit yourself, or do the best you can. It is an online program that you can access on your smartphone or on your computer that does a bunch of things academically relating to your executive functioning. It tracks your grades. It's a homework planner, so you can put your homework in it. It tells you when you got to do it. If you got a test coming up or a paper, it'll break it up into different events on your calendar and say, do a rough draft now, or do your editing now, and other things like that. What else?
That's it.
Well, it's free for the first month. Come on, say things.
Right, I know. I'm an. Ow.
I wasn't gonna hit you.
Ow. You can put in a test and it will build.
What? What do you? I can't understand what you're saying.
You can put in a test and it'll build a study schedule for you.
Oh,
So if you put in a test 2 weeks out, it'll say study for 20 minutes today and 30 minutes the next. It depends on you, and then you can customize it from there. You can do the same thing with a paper that you got that's due in a month or something like that, so you don't end up pulling an all-nighter farhand.
Farhand.
Also,
Yeah.
it will do Nerdish as well, so you could throw in Nerdish 8 to 9:30 p.m. Eastern Time, Tuesday, Wednesday, Thursday every week. And it'll tell you to go check out Nerdish.
Hey, you go check out Nerdish. That's what it sounds like.
Yep.
It alerts. It makes you little notifications where the little man says that.
I will give you, maybe you can't see this, a Thin Mint, if you ask a question.
It's literally so thin, and you turn it on its side, and it's not as thick as it looks like from the front. It's that thin.
Hmm. I'm gonna have to erase some of this. Maybe not, actually. We're gonna do number 13. Okay. Number 13 here. If we always want in the writing section to look at the answer choices first, see what we're dealing with. We have spend, spent, spend, to spend, having spent, these customers spend. And let's ignore no change for now. So, clearly has to do with verbs, right? There's a difference between spent and spend. So we'll be dealing with tense, most likely. But there's also something else that I want you to notice. If we have an infinitive verb here, the past participle here, right, having spent, or that's past progressive, whatever it is. I always forget. It doesn't matter. Past tense-y type stuff here. But most importantly, in B, we have the subject. B says these consumers spend. So we've added in a subject, which means we're definitely going to be looking for independent clauses here. Because B has an independent clause in the answer, but it's not in the other ones. Happy Pi Day, Jay. What's up? Do you have any questions? Or pie?
Accent.
We got... What?
Accent. You're a sheriff.
Welcome to Circle Town, Jay. I'm the sheriff around here. There are no other sheriffs around here.
Hey, that's not true.
No, there is no sheriffs around here.
There are no sheriffs around here. There is a second sheriff around here.
Right. Also, I like that Jay the Whiz Kid said, Happy Pi Die. No one caught that.
No, we
that's
caught
right.
it big time.
Anyway.
Big time.
Jay the Whiz Kid, we're so glad you're here.
Yeah.
We're so glad.
Don't go anywhere.
Stay right there. Hold your breath. Tense your body. And then explode. Blast off. Right?
Of course.
Yeah. All right. So, Jay the Whiz Kid, if you have any questions, please let us know. Put them in the questions. Put them in the Discord. Whatever you want to do until you've done that or said something else silly to which we can respond. I'm going to finish explaining this question number 12. Now, we have an independent clause situation. Ooh, angles and arcs. Are you sure, Jay the Whiz Kid? We could do that. Angles and arcs. We didn't actually talk much about arcs today.
Arc lengths?
We talked about arc length for a hot second.
Oh, you're right. Yeah, just arcs themselves.
Yes.
All those rules.
Now, let's see what's going on in this sentence for. Oh, I said 12 meant 13. So let's read this sentence here, starting with in. So, in the name of health, spending $1.60 for every dollar they would have spent on food that is grown in a manner conventionally grown food. Okay. So I have an issue here. We need to find our independent clause. This is super duper important, and we know that B has an independent clause within it, and these other ones do not provide us with a subject. So if we found the subject in the sentence and there's only one independent clause, B is going to be wrong. So let's see. In the name of health. Let's ignore that. That's just a non-essential at the beginning, in 1913, in 1492, whatever it might be. So, ignore it. So we could either say, these consumers spent $1.60 for every dollar they would have spent on food that is conventionally grown. Or, let's start with A, spending $1.60 for every dollar they would have spent on food that it... All right, I think in this sentence here, we need a subject that's not actually there. So B is actually going to be the right answer. Also, J, you said C, so let's see, having spent. Now, I see where you're coming from here because you're looking for something that sounds good, right? And starting off with having spent $1.60 for every dollar they would have spent on food that is conventionally grown, Yeah, that's fine, because you have would have spent here, right? Maybe that's what you're looking at, and then you said have and spent. Not a bad idea, but we don't actually have an active verb with its subject in this sentence. So they all sound pretty good starting out, but you don't actually have that independent clause. That's why it's important. So B is the right answer here. These consumers spend $1.60 for every dollar they would have spent on food that is conventionally grown. The answer to 14 is conventionally grown. That's a concision question, redundancy, whatnot. Now, it's important to recognize this and also important to prove 3 wrong. In this case, we have different tenses and verb usage here. Is have and spent an independent clause? No, sir. Independent clause needs a subject and a verb. You do not have a subject here. So, B is the only one that actually has introduced a subject to this sentence, and we need that. That's why it's important to look at the differences between the answer choices. Here we have verb and a different verb and a different tense, or same verb, different tense, but then B has put in these consumers spent. It gives you who's spending, which you should say, okay, well, if I have a subject already in my sentence, B is no good. But we didn't have that subject, we had to have it. That's what makes A, C, and D wrong and B correct. Oh, so you would definitely find that out. Yeah, I think it's not necessarily that I always know what's going to... Will most questions be that easy to discover with a verb and a subject? Please tell me if I'm being extra annoying and can't fully understand what I'm saying, or it pisses you off too much with this dialect, because it is annoying, I think, and mildly disrespectful. But whatever. It's not so hard if you know what you're looking for, right? So if you just read this sentence, you might not pick up on the fact that you don't have a subject, because it starts out nice. In the name of health, spending $1.60 for every dollar they would have spent on food that is conventionally grown. And the sentence gets long, and then you also have to fix this other part of the sentence in the next question, and that can be tricky. I would recommend, I strongly encourage, I recommend, I support the idea that you should look at the answer choices and see the differences. Like number 12, we have the purchase of, purchasing. The purchase of is a noun, right? That's a noun. That's not saying someone's purchasing something. There's no verb there. It's the purchase of. So that's a noun. See is the present participle of purchasing, so it's a verb, sort of. Then we just delete the whole thing. So that's what we're looking for. Do we want to say purchase here? Something like that. Here we have verbs, okay, and there's tenses, so we need to maybe keep in mind tense, and maybe that's where you got C from to match the tense later in the sentence. But we also have B, which is different from the other ones because it introduces what seems to be the subject of the verb. These consumers spend. Keep an eye out for that. I'm not saying you should have before. I'm saying you should from now on. Okay? Look for that. It will make the questions easier because this test is not testing you on stuff that you really can't do. It's just giving you stuff that you're not used to seeing because they want to see, can you apply what you know how to do in normal situations to slightly less typical ones. I hope that made sense. It is very interesting. The writing section is specifically responsive to you identifying question types because it will show you what you got to do. Right? If you see a semicolon, you know you're dealing with independent clauses because there have to be independent clauses on both sides. Just do that. If you don't pick up on it, then it becomes harder because then you're saying, oh, well, I think this one sounds nice. College Board is tricky. Yeah, it's tricky. They are trying to make you uncomfortable doing things that you think you're comfortable doing. But that's how it should be, I think. And they make money off you. That's more what they care about, is my guess. Any other questions? Is that one? Yeah. I actually, Bird.
What?
Reading scores versus math scores, are they generally the same? Or Jay is asking, is that why math scores are usually higher than reading scores? Is that true, like generally?
I've never heard of that before. I thought they were generally try to be average. Like they're what am I trying to say? They're scored in a way that you get the average student getting the same on both. I'll look this up though.
Yeah, I actually have no idea.
if math is higher than reading or vice versa. But regardless, what I will say is that the math section is pretty similar to what you see in normal math class. Relatively, the general structure of the questions is pretty comparable, right?
Right.
Mm-hmm.
Evidence-based reading and writing, the national average is 536, and for math it's 531. So they're pretty much equivalent.
Okay, they're equivalent essentially. So if you have more trouble on the reading section, it's very possible it's because the reading section is not the way you're used to dealing with questions when you're doing reading stuff, right? When you're reading for class, you read something, you analyze it with your class, and you write some essay on it, right? That's generally the structure of reading classes in later years of high school. But for the math section, it's kind of what you do in high school, right? You take tests and you answer questions, and they're numbered like that. You don't have as many numbered questions in reading class. It's more discussion based, and that's the way it should be, but they need to make this a quantifiable test. So it might just be that it's different, so you're not super comfortable with it, which is why you got to make yourself comfortable. Yes, and people are willing to do scandals. That's very true. Do you have what do you got? Evidence-based. You're talking about you, I assume. Is that an exclamation point? Are we saying that you're happy? I can't quite tell if that's just an extra L or an exclamation point. I hate this. It is an exclamation point. Very good. Okay. Dang it. Right. 59th percentile. Right. Just trying to mirror you. I don't know. I don't know what you're into. I don't know what you were shooting for. I don't think the percentiles are. I mean, that's what colleges look at, but it's not how you should, value your self-worth. I mean, I feel proud that I got a 940 because I feel like it's a strong enough base, sort of. Yeah, there you go. That's if you're starting at 940, like there we go. Then that's good. And you seem to be dedicated, and honestly, my guess is that if you are willing to put in the work and also watch SAT tutoring on Twitch, which is arguably not that exciting, then you're going to be fine because you're going to work hard enough to get yourself into a good enough place to keep working hard, and you'll be happy. Nothing will ever be wrong. Ever. Brady? Yes.
Duh.
Yes. Say yes.
Yes.
Yes. Yeah. The reading section is hard. I know you've heard us say this a lot, Jay, but you got to read and read and read. Okay. Deal. And we'll subscribe to your channel. Oh, okay. Well, wait. No, they're not here. Never mind.
Ooh.
Somebody subscribed yesterday, but I forget who it was.
Is it Hater Tot?
It was Hater Todd, yeah. Yeah, if you subbed, well, no, I mean, I would prefer not to trade subs with you, Jay, because then we just lose money. We give it to Twitch, so let's not do that. Got it. I mean, 1600s don't really matter. A 1600 will not get you into a school. It will not keep you out of a school. But like bumping up from, your base is that 940. You work from there. If reading is the toughest, then read all the time. One wrong answer doesn't. It can. On the last test, I know that it depends on what question you get wrong in what section, but you are. Cool. That's good. That is, people, are very frugal and then they buy junk food. And if you think about it, like one thing of junk food is a year's subscription to online New York Times or something like that. So just
don't eat junk food once and get the New York Times subscription, and then you can read a lot, and it's interesting, as long as you're committed to it. I hate reading the news personally. Brady sends me links, and I just don't read them.
Wait, why?
I don't like reading the news.
Why don't you like reading the news?
I don't like it.
What about it?
I want to read fantasy books.
Yeah, but the news is like your world.
I like listen. Like I'll listen to the news. I do podcasts.
Yeah.
News is very depressing. I agree. Yeah, the sensationalized front page news, I would stay away from that ideally, because then you're stuck doing that stuff. But there's a lot of news, and there's a lot of positive news, and a lot of just pretty neutral, interesting stuff. I would say go for that. Don't make yourself unhappy by what you read. It's, to an extent you want to be informed, but also no point in thinking that bad things happen all the time, constantly to everyone around. It's not really the case.
I don't know. Brig,
What's up?
Jay wants to know how many articles you should read per day. So getting the New York Times subscription, how many articles per day should they read? I would say one would be great. If you can read more or want to read more, then do that. But you want to, I would say, work your way up. So read one article. I would say, start with something, because if you start with 4 articles a day, it's probably unsustainable. You don't want to do something that's too much and then you fall off and give up entirely.
You set a low bar,
So,
right?
Yeah.
I have a subscription to a newspaper that I have it goes through an app, so I can just scroll through an app and see the articles. I read the articles that I find interesting looking. They might be all sorts of different things. They post these articles in order of like how like big news they are, and then as you scroll down, you get to like the less and less big news. So I start at the top and I see if anything looks interesting, and then I read it. And if it's not interesting to me, I don't read it. Don't get too caught up in like a quantity. Just think to yourself, like, what looks interesting to you? What do you want to know more about in the world?
Call mom.
And just don't call mom. No, I hate when you do that. Okay. It doesn't know. Does your voice actually?
I don't know.
Even when you press the Siri button.
I'll say call Levi.
Yeah, Jay. Then you should read.
Call Levi.
You should read science articles.
Call Levi.
There's always a science section. There's like a bunch of different, like sports, science, arts and health, or something like that. Arts and health. No. Arts, things like that. Yeah. Just go to the science ones. They're pretty wild.
Yeah. I would say it might help to identify a part of the day where you just go on your phone and do putz around and do nothing productive, because you can actively say, okay, during that 5-minute period when I'm always doing something worthless, I'm going to read during that period.
Ooh, press the button.
I'm going to press a button.
Discord question posted.
Yes. Okay.
I'm so excited.
Discord,
Discord, my lord.
Discord, my lord.
Nah. Compare and contrast President Truman's application of the policy of containment to President Eisenhower's. Which do you believe to be the most effective? Why? Include examples to support your answer.
Oh, that's easy.
They had different names.
Yeah, okay, so they're talking about communism here, which is all I got. It's been a while since we took this. I kind of forget exactly how their containment policies differed. There's also Domino Theory, which is like, if you let one country fall to communism, then all the countries around it will fall to communism, and then the whole world will fall to communism. And that was kind of the justification for the Vietnam War. Truman Doctrine. Ah, the Truman Doctrine. That sounds fun. Yeah, let me look that up for you. I mean, we just have Google at this point, so I wouldn't really... Okay. It was to counter Soviet geopolitical expansion during the Cold War. Direct American military force was not involved.
but Congress appropriated financial aid to support the economies and militaries of Greece and Turkey. More generally, they implied American support for other nations allegedly threatened by Soviet communism. Interesting. Okay. So basically, you support the free people close to the Soviet Union so that they can defend themselves, rather than like actually jumping in to the war yourself.
The war effort.
The war effort! It's important to conserve metal for the war effort.
The war effort.
Plant a victory garden. Grow tomatoes for your boys overseas. And what about Eisenhower? So I lived near a highway growing up that was like called the Eisenhower Expressway. So whenever I think Eisenhower, I think of just the sound of like a highway, just like cars going by. And that's President Eisenhower. Let's see. The New Look was the name given to the national security policy of the United States. This is just Wikipedia.
Get you a friend relationship like
It
Levi and
reflected
Bird.
Eisenhower's
Hey.
concern. Hey, come on. Yeah, all right. Don't bring that up. It reflected President Eisenhower's concern for balancing Cold War military commitments with the nation's financial resources. It emphasized reliance on strategic nuclear weapons to deter potential threats, both conventional and nuclear, from the Eastern Bloc of nations set by the Soviet Union. Interesting. Okay. So in order to conserve financial resources, it emphasized strategic nuclear weapons. That's very interesting. The more weapons you have, the less people are going to do things that piss you off. Which was a great policy until other countries suddenly had nuclear weapons as well. Because if you're only one on the block with nuclear weapons, you are going to set the rules for when other people get them. And I'm not making this up. This is Dan Carlin, who is a podcaster who I love.
So I feel to compare, Eisenhower's promoted violence and showing big guns, and Truman was all about protecting countries against
So
violence.
here's the thing about violence and showing big guns. Those are not exactly the same thing. There was the Roosevelt corollary. No. There was Theodore Roosevelt who said, speak softly and carry a big stick. So basically, you do not need to actually be physically aggressive. You can be more calm, but if you show that you have the resources to carry out a war if needed, people aren't going to mess with you. That was sort of you're carrying a big stick. There's this idea of peace through military, right? The United States has the largest military in the history of mankind. And because of that, people do not attack us. So there's at least a measure of peace on our soil, not necessarily on other people's soil, just because of the military that we have. So like promoting violence, I don't exactly think is what he wanted to do, but he wanted to not have communism, continue to expand into Europe. And one of the ways he did that is a show of potential force using the weapons, I think. I am just speaking on my butt here.
Yes, so am I. I'm just thinking of different, because since I know nothing about history and I remember very little, unfortunately.
Levi, what year was the founding of the United States? Please know this.
Like founding like the Articles of Confederation or
No. The Declaration of Independence.
1776.
Good.
July 4th.
Good. It's actually ratified on the 6th, but
Was
I
it?
don't really care about that. Yeah. Brinkmanship. Yeah, I don't know who that was, but that was another fun part of it.
I had a mom like that.
Brinkmanship?
Yeah.
Yeah.
So these are things that could maybe be ways that you can compare and contrast them. I'm really maybe not being helpful at all. Totally possible. In which case, say this is done, and then you'll never ask us a question like this again because you can tell that we don't know what we're talking about.
Yeah, we're ACT, SAT boys. I'm not sure we're the best resource for
So
you.
support of the common people in the country, support of the allies, and support of the main political factions in our country. Those could be ways that you could compare and contrast them. Those sort of go together. And then locations of interest with regards to those two doctrines, why we did them, the stated goals, it's kind of the same thing, and then how successful were they, and then why. All of those things.
Yes, it is past 9:30.
Is it?
Yes, it is.
It is.
Very well. I believe Pi Day is still upon us, but we will be celebrating it by ourselves from now on. No longer with you.
Never again.
Never again until the next Pi Day.
Yes.
Yeah. If the world hasn't been embroiled in nuclear war by then.
Nuclear war.
People act as though now is more dangerous than the Cold War, but it's not. Like, the worst thing that could happen is, like, terrorists get a hold of, a dirty bomb, which would be really, really, really bad. Don't get me wrong. But the threats that we had in the 1950s and 60s and 70s and 80s were full-on massive global nuclear holocaust type situations.
Well, that was because there were more like X-Men around, and there were some mutant problems.
Right, X-Men. Angles and arcs.
Oh my gosh.
Angles and arcs.
Sorry, let's do that.
Oh no.
Do you have anywhere to go?
No.
Yeah. Whatever. That's our fault. Okay, angles and arcs. What kind of angles and arcs? Are we talking sector? If you're given theta is 35 degrees, how do you find the length of that arc? Is that what we're talking? Brady wants to leave me.
That's not true. I just want to leave the situation. You'd happen to be there. So I can see how you construe it that way, but it's, not necessarily that way. All right, well, there's two kind of rules here. There's like the angle inscribed at the center, and then there's the angle inscribed at the edge of the circle. I think there are more rules, but for now, yes. Now, when you say arc, do you mean arc length or just arc measure? Because they're kind of two different things, or maybe both. Because if you got a sector that's like, I don't know, 35 degrees, as long as this is inscribed in the center of the circle, this arc will measure 35 degrees. It won't be 35 degrees long. It'll be a different, you'll have to know the radius and then the circumference and all that stuff. But this will be 35 degrees of arc.
Jay, is this what you're dealing with here? This type of thing? Like you're given theta, you're given radius, and they say, what is the arc length?
Degrees of arc, this stuff. Yeah,
Dang it.
Sorry. So you have an angle centered at the center, inscribed at the center of a circle. It's going to be the same measure. If it's inscribed instead on the edge, let's say this is 20 degrees. The measure, hey, come on.
Yep.
The measure of the arc, no, I know, is going to be twice that. This is going to be 40. Okay? They call it a minor arc. So like if this was AB, this would be minor arc AB because there's another arc that gets you from A to B, which is the long way around. That's called the major arc. Yes, we've learned that. Very good. Are there any specific problems on your homework or on your unit review that are troubling you? And you can send them to us, because we can try to take a look at that. Otherwise, I'll just be holding these massive beach balls. Sorry. I got carried away. One thing you should know is that if there's an angle that's inscribed in a circle, and it opens up to a diameter, like this, because it's opening up to an arc that's 180 degrees, this has to be half of that. This is a 90-degree angle. All right, you could adjust that here. It's still a 90-degree angle. Anywhere you want to put it, it's always going to be 90 degrees if it opens up to a diameter. All right, I sort of don't want to get off your runtime, boys, so it's fine. You appreciate that. What do you think, Levi? 5 more minutes? What? Oop. You have that line that shows up on the edge of the circle by the right angle. What's going on here? Minutes left. Oh, pi minutes left. Yeah, we'll give you some pi minutes. On the edge of the circle by the right angle. Are you talking about a tangent line? That might be what you're talking about, because that is also taught. So you have a circle, and you have a line that's tangent to that circle. Yes, okay. So any line that's tangent to a circle touches it at one point. And because of that, if you draw a point where it touches it, and then connect that to a radius of the circle at that point, that's going to be a right angle. All right, so like, you know, if you got two different tangent lines, that's two different right angles. Geez, I don't know. What else? I mean, just come out here, leave.
They might give you a problem like this, and then they say that this is 40 degrees. And then they say, what is the length? Oh, this is interesting, Bird.
What?
If this is 40 degrees, and these two
our tangent lines, what is the length of this major arc here? So
fun.
you can work your way through this. I'm sure there's a rule to it, but you know this is 40 degrees. You know this is 90. You know this is 90. You could say, well, the interior angles of a quadrilateral, which this thing is here, add up to 360. Or you can make this into two triangles, and this is 20 and 20. And you can just look at this triangle. This is a right triangle with 20, 90, so this has to be 70. And if that's 70 and this is 70, then you have 140. Yeah, very exciting, right? And then from here, if this is 140, then this arc here is going to be 140. So the length of this big arc here will be 360 minus 140, which is 220. So if you have tangent lines that meet at a 40-degree angle, then this is going to be 220 degrees. There's a rule, maybe, but that's what you got to do. It's with this type of thing, if you're dealing with circles, you're looking for triangles. That's what circles do. They give you triangles. They give you right angles. Triangles are the most important polygon for sure. Draw in radii. You always want to be drawing things from the center of the circle to important points on the circle, or in this case, important points on the tangent lines. You know the tangent lines hit radii at 90 degrees. What's the what for? No, we don't have superpowers in math. That's not the case. That's not true. You're a dirty liar, Jay. You're throwing math at these things. Remember, you've learned a certain number of things that are... you learn a certain number of things about circles and these angles and things like that. So it's not that we know where to go. Although after a while you think, oh yeah, I just should do this and I figure it'll work out. Yeah, it is fun. I mean, we're good at this math because we've been doing this math for a long time. Next year I'm taking Algebra 2 accelerated. My geometry teacher says it's a big push. Yeah, Algebra 2 is hard. Geometry is hard. I honestly thought geometry was very hard because the proofs were just mind-numbingly dumb. But at least there are no proofs on the SAT or ACT. It is about throwing math at the picture. Right? You know about radii, you know about circumference and area, you know about this relation, this proportion, you know about inscribed angles, things like that, and you know about tangent lines. So that's what you're dealing with. I mean, if you have something like, maybe you've seen us do this problem before. Ugh. Bird. Whatever. You always want to draw in radii. You want to just throw math at it. So that's what I did here. They give you some information, and there is a path to reach the answer from the given information, right? Or unless there's an answer that says it can't be determined, which is hard. But we're assuming that there's a path. So start building from what you know. We knew here we had tangent lines. The only thing you really know about tangent lines is that they touch the circle at one point, and the radius to that point is 90 degrees. You put that in. Now, 90-degree angles tell you angles, and we had a quadrilateral here. If you remember that 360 degrees is the sum of the interior angles, great. If you don't, you draw in a line where it would matter, which is from the center of the circle out to there. You notice you have right triangles. Right triangles should just, be very, very clear to you at all times. You're always looking for right triangles because they give you so much information. That's what we have here. And then you can, that'll bisect that angle, of course. You have 20 and 20. And then from there you can work your way. And then we get back to this stuff with the central angle and then subtraction. It's not about I know exactly what to do. The only thing you really need to know is the nuts and bolts of the information, and then to throw all of those things at it and see, oh, well, that reminds me of this, and I'll throw that at it and see if it works. Okay. Brady, we have to go.
I know!
You're always making the stream take too long. How?
Oh. Looks like this town was big enough for the two of us after all.
Don't worry about it, Jay the Whiz Kid. It's on the house. But next time,
You're gonna have to pay. We're also brought to you. Wait, here we go. We appreciate you too. And we're also brought to you guys by Tight Bond Wood Glue, because Levi and I have a tight bond. Toy. Ha ha ha! Accord. Very good.
Comp dude.
That's another Pi Day joke.
Very nice.
Computer dude. It's a dude with a computer.
Yeah.
I wish I knew someone with a computer.
Maybe not. Maybe comp dude is an angle, looking for his other comp angle dude.
Maybe you're a bozo
I am a
hanging out with a
bozo.
clown. How about that, huh?
Uh-huh.
Hey, that's not what I thought was going to get
Happened when
transpired.
I squeezed your nose.
Yeah.
Hey, comp dude, you're late. Where are you from? Oh, yeah, we can do that. How did you get here?
Ah, he's got all the books. He's got all the
Earth.
books.
Doubt it. You're probably an alien. Or a robot. Robots are from Earth.
Honestly, what's the difference? If you're an alien that's sophisticated enough to get off your own planet and start exploring the universe, at some point you're just going to take your consciousness, you're going to upload it to like some kind of like a robot that's got more physical capabilities than your own.
That's
physical
true.
body.
Carbon-based life forms are inherently going to break down. That
Right.
makes sense.
Right. I think I'd prefer to be a robot. IQ is not useful. It's hard work and determination. It is a combination of everything, like everything else. Albert Einstein would have been nothing without his hard work and determination. Yes, that's very true. That's very true. It definitely takes a little bit of both. But, you'd be surprised. People that don't have a lot of one can compensate by having a lot of the other, and vice versa, and all that stuff. Yeah, it's always a combination. Is it nature? Is it nurture? Well, it's both. Who knew? How much of it is a 1% and a bit of quiet time at the patent office? I don't know my IQ. Yeah, people don't really get their IQ tested anymore. I mean, occasionally, but it's like a several hour long. No. It's a several hour long procedure that's like a psychological thing, like a study that, or like a test they sit you through, and you have like basically a proctor. It's like one-on-one. They really don't do that much.
I heard there was a big scandal with it where people were taking the IQ test and then they were paying
The parents
like,
were paying
thousands of dollars.
Exactly. Yeah. My brother's fiance knows hers because she had a friend in grad school.
Tell Jay.
No, but she's a smart cookie. Oh, I will say that.
For a fiance.
Yeah, sorry if I didn't. For a fiance, yes. What's her IQ? It's pretty high. I forget. I'll have to ask her. But she's a smart cookie. I don't know her. Yeah, I just, because like legal ramifications and things and honestly, fiscal consequences. Fiscal. Fist to skull.
Skull.
You get it. I mean, if I told you I'd have to
Fiscally.
die eventually after hopefully a long life, and I don't want to have to do that. I'm a known lawyer. What other kind of lawyer is there? You gotta be a known lawyer. Yeah, we gotta go.
Yeah, we do have to go. Okay.
Please square the circle. Well, we could do that, but it's okay. Good night, guys. Square the circle. That's something that the ancients wanted to try to do. Figure out how long a square would have to be to have the same area as a circle.
How long?
Yeah, so like if you draw a circle completely inside of a square, the square is too big. They want a square to have the exact same area as a circle. So
make it a circle.
all
Well,
right.
how do you make it long
You
enough?
see what I have to deal with on a daily basis? God.
Wait, Bird. Uh-oh, what have I done? Night,